Hi, kids. Okay, so you might ask, well, why do I have Newton's first law? Newton's first law. Why do I have it written down? Well, Newton's first law is really the key to all those demos that you did, as far as why does the water stay in the bucket? When you spin it. Why does the penny stay on the hanger? Why the paper plate puzzler? It's really the key to this. So remember, the key is an object in motion stays in motion along a straight line or it's the object rest stays rest, unless acted on by a net outside force. So, for example, the paper plate puzzler one, where you had a paper plate that was kind of like this, where it was cut out, and you had a marble, and this marble was rolling around. It was rolling around, and then it got to here, and then it went straight. Okay. Well, why did it go straight? Because right there, it was moving up. So an object in motion stays in motion along a straight line unless acted on by a net outside force. Where when it was over here, it didn't keep moving straight. Why? Because the plate was pushing on it. Which way was the plate pushing on it? The plate was pushing it on towards the center. Down here, which way was the plate pushing on it? Towards the center. That was the net outside force. Okay? In fact, that net outside force was a special one called centripetal force. So centripetal force is a special net force that causes an object to move in a circle. Okay. Remember, to accelerate, if there's a net force, you're going to accelerate. To accelerate, you speed up, slow down, or change direction. Well, centripetal force, which we're going to be calling, a lot of times we're going to call that FC for centripetal force. But I want to make sure you understand it is just the net force. Okay. It's not like, when we were doing this from before, and we said, well, I have this force, and then I have this force, and I have this force, and if I call this force 1 and force 2 and force 3, to find the net force, you would say F1 plus F2 minus F3. Okay, that would be how you find the net force. Well, in this case, this is a top view of the paper plate, so you would have the force from the plate going this way, and then the force of gravity would be going like into the page, and the normal force would be coming off the page. So I'm not going to draw those. But hey, that's my net force, the force of the plate. It just so happens that net force, the force on the plate, is also my centripetal force. Okay? It is important that the centripetal force always points towards the center of the circle. Okay, the word centripetal means towards the center. Okay, if you have a matchbox car going through a loop, so I have a loop here, and you might think, well, if you were to draw your FPD at the top, well, if you were to draw the FPD at the top, you would have the normal force pointing down, you would have the gravity pointing down. And that's it. Those are the only forces acting on the car at the top. Well, geez, wait a second. If I have the normal force and the force of gravity, look, my net force is pointing towards the center. These two forces together would be my centripetal force. Whereas if it's at the bottom, you would have the normal force pointing up and then the force of gravity pointing down. Well, again, if it's going to accelerate towards the center, which one of these forces has to be bigger? Yep, the normal force does. So in this case, it would be Fn, you'd have the centripetal force would be Fn minus Fg equals the centripetal force. I don't want you to think, oh, well, the normal force is the centripetal force. No, it's not. It's the net force, okay, that you get when you add up all the forces acting on it, okay? But that's what I mean by centripetal force. The reason that we don't use the F word, okay, that this, okay, is what's called centrifugal, and I'm going to say it right now, but we're going to stop saying it in a minute, means away from the center. That a lot of times, if you've ever been on, the gravitron, where you're on the thing where you get stuck to the wall, you're spinning around. This is a side view of it, but you're spinning around. If you wanted to do a top view of it, there's you, and this thing is spinning around, and you get stuck to the wall. Well, if you've ever been on the gravitron, it truly feels to you like there is something pushing you outward. If you've ever been in your car and you go around a corner really fast, it feels like you get thrown to the outside. Okay? And people are ignorant. So they said, well, I don't know. It feels like there's a force acting on me. So I don't know what that force is. So I'm going to call it the Centrifugal Force. And no, okay, that there is no force pointing outward on you. Okay? Why do you feel like you get thrown to the outside? Newton's first law. You're trying to go straight, and in this case, the wall is preventing you from going straight. Okay? That if you did the one with the water in the cup, and why does the water stay in the cup? Well, that water is moving. Okay? If you do that demo and it's not moving, it's not going to be a very successful demo. Okay? In fact, if you want to film that and, send me the video, awesome. Okay? But that if that water, if I'm spinning a bucket of water in a circle, okay, at the top, that bucket of water is trying to move this way. Well, what's preventing it from moving that way? The bucket. So the reason the bucket stays in, or the water stays in the bucket, is because the water is trying to move in a straight line, and the bucket is getting in the way. Okay, the bucket is forcing it to move in a circle. Same thing here. The Matchbox car. The Matchbox car stays in the circle here. Why? Because it's moving, and it's trying to go in a straight line. In this case, if it's going around, it would try to be moving that way. But because the track is getting in the way, and gravity is also helping it, that it's going to move in a circle. Okay? So centripetal, yay. Centrifugal, gross, disgusting. In fact, see there's a little F here. If I ever see you, or like see you hear you say this word, or like you write this word, I'm just gonna write your referral to the dean and say, hey, Johnny used the F word in class. So, good luck explaining that to your dean. So this one is not real. It comes about because it feels like there's an outward force on you. This is the real one. Okay. And again, why does it feel like there's an outward force? Because of Newton's first law. You're trying to go straight, and something's getting in the way. All right, bye, kids.